Okay, so this module will be talking about the periodic table, which is chapter or subtopic 4.1. So essentially, the periodic table was discovered by a Russian scientist called Dmitry Mendeleev, and he discovered the periodic table as a way of organizing and classifying the different elements. The elements are classified based on their atomic mass. Their atomic number, which is given at the top here: 1, 2, 3, 4. These represent the number of protons and also the number of neutrons in that particular atom. So for example, there is 1 proton in hydrogen, whereas there are 0 neutrons, and there is also 1 neutron. Whereas in this, there's 2 protons and 2 neutrons. And since we know that the atomic mass unit of a proton is approximately 1, and the atomic mass unit of a neutron is approximately 1 as well, when you add 2 protons and 2 neutrons, you would get an atomic mass of 4 atomic mass units, which is almost equivalent to the atomic mass number of helium here. So there are several different groups in the periodic table, and they're based on, and these groups are essentially the vertical groupings, and these groups have similar chemical and physical properties because of their atomic structure. Those in the first column are known as alkali metals, and alkali metals have the same thing in common as they only have 1 valence electron. The next group is known as alkali earth metals, for example, beryllium, magnesium, calcium, strontium, barium, and radium. And these elements have 2 valence electrons. Then the middle area is known as the transition elements, which we'll skip for now, and we'll get back to later. Then finally, we have a group, then we have the penultimate and the final group. The penultimate group is known as halogens. They have 7 valence electrons. And the very last group is known as noble gases. They have 8 valence electrons. Or in the case of hydrogen, 2, or helium, I beg your pardon, it's 2. These noble gases are have complete outer shells and can no longer be added to complete the outer shell, as in they have no desire to gain or give away any electrons, because they're already in a stable state. So the most reactive of these groups are halogen, group 7, and alkali metals, group 1. Because for halogen atoms like fluorine, etc., if they gain a single electron, they will become a noble gas. Whereas an alkali metal, if they lose an electron, they will also become a noble gas. Okay. The next thing we'll need to look at is transition elements or transition metals, which exist within this area. Unlike the other elements in the various groups, these have variable oxidation states, which means that they can exist in more than one way. This is the key difference between transition metals and the other elements.